Hello, my name is Patrizia Bolzan. I have a PhD in design and I'm a research fellow at Polifactory, the Fab Lab and CAD Center of Politecnico di Milano. My background is actually far from textile field because I'm a product designer and usually I work with product design students. So why I am here? Because during my everyday job, I explore the connection between digital manufacturing technology and design processes and practices. This relationship is interesting and possible thanks to the change in production process and models from the design perspective. So, in this course I want to give you some information about the possibilities offered by digital technologies when they are applied to the textile field, in particular when you want to experiment in it. In fact, the possibilities offered by the current technological accessibility favor a paradigm shift thanks to the use of digital fabrication machines, such as laser cutting and 3D printers. In a scenario where small production series are becoming increasingly common, the gap between conception and implementation production has been decreasing substantially. The new possibilities offered by digital technologies also contribute to this. And the new possibilities offered are very important for the textile field, where production runs ranging from limited edition to mass production. So, a change is in progress. What we can trace this change back to? Three main drivers have triggered this change: democratization of technology, customization of production, and independence of distribution. By democratization of technology, I mean that now you can reach technologies that were previously rare and expensive. And one of the main examples is precisely the digital manufacturing technologies, which in the past were exclusive legacy of the industry because of their cost and the complexity of the software that controlled them. In connection with that assumption, also customization of production is possible in a more pervasive way, thanks to digitalization of the production that give us the possibility to create, share, modify ideas directly with the digital files. And the possibility to produce what you want on demand and on site opens the way to new business models toward an independence of distribution. In this sense, when you are in the stage when we're still designing a new product or process, the most significant technologies are the ones that build the ensemble that is called digital fabrication, and where we can find this kind of technology. The Fab Lab is one of the places where it is possible to use digital technologies in a direct relationship with the machines. Fab Lab is an acronym for Fabrication Laboratory that is a small-scale workshop offering personal digital fabrication. A Fab Lab is typically equipped with an array of flexible computer-controlled tools that cover several different scales and various materials with the aim to make almost anything. What are the digital technologies we find in a Fab Lab? Mainly, these technologies can be divided in two macrogroups: subtractive technologies such as laser cutter, CNC milling machine, vinyl cutter, and additive technologies, or the machines that are commonly called 3D printers. In this lesson, we focus on what you can do through the laser cutter and the 3D printers, especially the two most representative and flexible technologies while working with opposite logics. Let's go to see what you can do with the laser cutter. Laser cutting is a non-contact process which utilizes a laser to cut materials, resulting in a high-quality, dimensionally accurate cuts. The process works by directing the laser beam through a nozzle onto the workpiece. A combination of heat and pressure creates the cutting action. For example, you can create objects, cutting slices of materials. You can create accessories where cutting and engraving process give flexibility or three-dimensionality to the flat material. For example, what you can see in this image. Or you can also create garments and use laser cutting to make voids and decoration. The important thing is that this technology allows great flexibility combined with fast production, so it can allow you to create countless design solutions. Generally, laser cutting can be used for basic or advanced applications. For example, you can use this technology to reproduce auxetic structures, which can act not only as patterns but also to break down the two-dimensionality. In this image, you can see the example of palpatine, a bra made from a single sheet of fabric, which thanks to an auxetic structure, obtains a great wearability and interesting decoration. A further application of this subtractive technology is the creation of paper patterns. Laser cutting can be used to cut the paper pattern directly onto fabric, paving the way for a zero-waste design approach. With the head of the laser, in fact, the edge of the fabrics, based on synthetic fiber, will be automatically welded, and the pieces will be usable without creating hems. The latest application of laser cutting presented in this module is called modular fashion. Modular fashion is an approach to the production of accessories and garments using vector graphic design of bidimensional laser cut modules. I want to show you this video that displays the laser cutting process in real time during the production of one of the modules for modular fashion. These modules are then interlocked to create complex 3D seamless geometry. In this video, you can see cutting, half cutting, and engraving operation. As you can see, the engraving operation, the words that appear on the fabric, takes more time and consequently has a higher production cost because the machine follows a raster logic. Meanwhile, when the machine performs the vector cutting operation, which are the edges line, it is evident that the efficiency increases. However, some thicker fabrics may require more steps to achieve a precise cut, and this is one of this case. Additive technology works in a completely different way. Additive manufacturing technologies are more commonly known as 3D printing. As designers, it is very important to know the potential and limits of the available technology. Additive technologies are divided in two big families: deposition processes and binding processes. When it comes to binding processes, objects are created through the aggregation of layers of pre-spread powder or through the curing of photopolymers. Among these technologies, the most relevant are stereolithography, or SLA for short, and selective laser sintering, also called SLS. Otherwise, when it comes to deposition processes, the materials are extruded through a nozzle that can be heated or not, depending on whether it's printed with polymers or with past extrusions. The most diffuse deposition technology is FDM, which stands for Fused Deposition Modeling. The interesting things about FDM machines, especially non-professional ones, is that they allow us to integrate other materials. For example, it is possible to print directly on fabric, also taking benefits of any relevant elasticity properties. In this time-lapse video, you can better understand how this process works. To stick materials together, you first print a layer, then place the fabric in tension, then resume the paused 3D printing. At the end of the process, all you need to do is cut off the exceeding fabrics along the edge of the printed polymeric parts. And here you can see how the elasticity of the fabric emphasizes the three-dimensionality of the resulting piece. Following the same principle, solid structures can also be printed directly onto fabric. In this case, making the same piece of fabric a series of modules divided among them, they may orient themselves in space depending on the surface that the fabric covers or on which it is placed. When you are developing the repeatability of the process to create small production series, you may want to consider creating a frame to encourage constant tension on the fabric. In this picture, you can see the results obtained from the previous manufacturing process, a mask for individual protection. 3D printing, as used for the production of wearables, offers the ability to produce parts on demand based on the end user's dimensions and size. So, in conclusion, we can say that technologies influence the designers and the producer, changing the aesthetics of the projects. It is possible to design and manufacture shapes that were previously impossible. And I hope through the topic addressed in this video, you have now increased your knowledge, skills and competence related to the connection between textile field and digital fabrication. Thank you and goodbye.